Welcome to Sundar's lecture. This is lecture number 9, and we have seen in the last lecture application of voltage division rule and the current division rule. We have taken a problem and we have solved the problem using voltage division rule, and also we have taken another problem, right? This one, and we have solved using current division rule. Now, in this class, I am going to explain the same thing. This problem, uh, it was solved by writing KVL expressions. Right now, I am going to explain the same method, the same problem with a different method. This method is called inspection method. It is very easy, and you don't need to write KVL expressions and directions of the current and so many things. So what you would have done, if you see this problem with the knowledge of KVL, you will take this is I1 and this is I2 and you draw the current directions I1, I2 here and there, and you try to write the KVL expression 1 and KVL for two loops you will have two expressions, and you would have simplified that, and you get I1 and I2. With I1 and I2, you can easily find what is the current flowing through these 2 ohms, 6 ohms and 4 ohms resistor. All those kind of things we have seen already. But now, you don't need to write so many expressions. It is a matrix method. How it is going to be, how we are going to solve using the matrix method, we will see now. See, first one thing, let me take a different color. You see, what is the formula for voltage? I can write R into I, which is equal to V. I'm just writing it in matrix, that's all. See, V is equal to I into R. That we know, right? That we know. We know this expression, right? V is equal to I into R. I have just written this in the matrix form. See how you can determine the R matrix here in for this problem. I'm explaining for this problem. Then you try to understand or you try to develop with this knowledge for the other problems, right? If this R matrix, what is the dimension of this R matrix? That depends on how many loops you have. See, first if you see the problem, obviously you take this, no problem. You take this is I1, this is I1 and this is I2. That it has to be done. It has to be done. Because this is loop 1, this is loop 2. Actually, this is loop current method. We always call this method as mesh current analysis method. We have done it in the by using KVL. There also you should call this method as mesh current method, because this is a single mesh or loop current method. Anything, it may be anything, right? No problem, right? So now here also you have to take this is I1 and this is I2. How many loops are available here? Two loops. If you have two loops, then this R matrix dimension will be 2 cross 2. Try to understand. This R matrix dimension will be 2 cross 2. If we have 3 loops, then this R matrix dimension will be 3 cross 3. That's all. And this I matrix will be one column, and how many rows, that depends on the loops. If you have two loops, this I matrix will have two rows and one column. This I matrix will be always one column, and this V matrix will be also like I matrix, right? I will write here anyhow. You see, I will write. So how many loops we have now? We have now two loops. So this R matrix will be 2 cross 2. So I will write with these values: R11, R12, R21, R22, and this is the R matrix expansion for this problem. And you see, all diagonal elements will be always kept in positive values, and all off diagonal elements will be in negative. These are all basics. These you should understand, right? Now we have to go for I matrix. I have told you I matrix will be a single column matrix always. and number of rows depends on obviously number of loops. So you see this is a single column, no problem, and this will be I1 and this should be I2. That's all, because I have two loops. If I have three loops, then I will have I3 in a single column. Right? Then this V matrix will be also the same. V1, V2. That's all. This is how you need to write the matrix format for the given problem. You see how many number of loops are available. That should be the dimension of R matrix, which means rows should be 2 and the columns should be 2 for a two loop problem. If it is a 3 loop problem, then rows should be 3 and columns should be 3. And this I and V matrix will have only single column, but number of rows, it is depend on how many loops you have. Okay, fine. Now I will tell you how to write this R matrix from the problem. You see R11, which means this, you see this is the first loop, this is the first loop and this is the second loop. You try to understand. Okay, first loop, first closed path, and this is the second closed path. R11 represents total resistance in the first loop. In the first loop, you have to write the total resistance. In the first loop, we have 2 ohms and 4 ohms, right? So, total resistance value will be plus 6. That's all. That's all. Very simple. Plus 6. And R12, which means first loop and second loop resistance, common resistance between loop 1 and loop 2. You see, this is loop 1 and this is loop 2. This 4 ohms resistance comes under loop 1 as well as under loop 2. So this is the common resistance. This 4 ohms resistance is the common resistance. So what you do, you just write minus 4. That's all, because minus is there in the matrix itself. And you see R21, common resistance between second loop and first loop. That should be same. That should be same. What is that? That is nothing but it is 4 ohms resistor. This 4 ohms minus 4. And R22. R22 means total resistance in the second loop. What is the second loop? This is the second loop and we have 2 resistor. If you total this, you will get 10, right? So this will be 10. That's all. Then I1, I2, we don't know. This is the unknown parameters. We need to find I1 and I2. Now you need to find what is V1. What is V1? First loop voltage. Whatever the voltage you have in the first loop, that you have to write here. Anyway, there may be a voltage source here also, right? We have not, it is not present in this problem. Anyhow, we will have. We don't know, right? Okay, fine. How you should find what is the voltage in the first loop? Try to go in this loop, in this direction. You start from here and you come over through this point to here. Again, you end here and you measure the voltage. Whatever the voltage you are getting, put here. That's all. You see, start from here, you go in this direction because my current direction is like this. So go in this direction. So I am going from minus to plus. What is the voltage? How you need to write the voltage value? If you are going from minus to plus, then obviously it should be plus 10. Plus 10. And I am going in this way, I am coming here, loop 1 has been completed. I don't have any other voltages. So plus 10 will be the final value. And you see for V2, now I am going for the V2. What is V2? You start from this point, my I2 is like this, right? Clockwise direction. So I have to travel in this way, there is no voltage, and I am coming here. Now you see I am traveling from plus to minus in the 5 volt. My current I2 is traveling from plus to minus. Then what is the value you should write here? If you are traveling from plus to minus in a voltage source, obviously that should be minus 5. These are all you already know, but this is a different procedure to solve the problem. Anyway, that's all. We have written the matrix format. And this matrix can be solved by using so many methods. You can use Cramer's rule or anything else to find I1 and I2. But I am not going to use those kind of things. I am just going to write the expression here. How? How will you multiply these two matrices? This row and this column has to be multiplied, which means this row, this column, if you multiply, that should be equal to what? This right hand side first row value. This is the basic max, right? How will you equate this one? You multiply this row with this column and you have to equate it to 10. And you multiply this row with this column and you equate it to minus 5. That's all, right? So I will write here. I will write here. So you take 6 into I1, right? 6 into I1 minus 4 into I2 minus 4 into I2, that should be equal to what? 10. That should be equal to what? 10. That's all. So this is the expression number 1. And this row and this column again, which should be equal to what? Minus 5. So minus 4 into I1 minus 4 into I1 plus 10 into I2 plus 10 into I2, that should be equal to what? That should be equal to minus 5. That should be equal to minus 5. That's all. This is expression number 2. We got the expression. We got the expression. Now we know to solve I1 and I2, right? Right? This is the problem we have taken already. Now let me solve this I1 and I2, get the values. And if I solve this expression, I am getting I1 is equal to 1.82 and I2 is equal to 0.23. That's all. Now we know how to find the current in 2 ohms resistor. What is the current in 2 ohms resistor? Only this 2 ohms resistor is present in the first loop. So obviously you know I2 ohms resistor will be equal to I1 and that is nothing but it is 1.82 amperes. And what is the current in 6 ohms resistor? This 6 ohms resistor is only present in the second loop. So this will be I through 6 ohms resistor will be I2 and that is nothing but it is 0.23 amperes. That we know already. Then what is the current in the 4 ohms resistor? That you need to find. How? How will you find? Simple. You keep this as node A, node A, apply KCL at node A. So put equal to the symbol that you already know. So you see this current, that means this is I1, right? So I will draw here in you. So this is I1 and this is I2. Let me assume this is I through 4 ohms, right? Let me assume. So you see I1 is coming towards the node. So I have to put it in the left hand side. And I2 is going away from the node. So I have to put it in the right hand side. And I through 4 ohms is coming away, right, again. So this will be I through 4 ohms. So if I solve, I through 4 ohms will be equal to I1 minus I2. What I will get? What is I1? 1.82 minus, okay, 1.82 minus 0.23. And if I solve this, what I am getting? I through 4 ohms will be equal to, so I through 4 ohms will be equal to 1.59 amperes. That's all. Now you see we have found all the values. Here also the same procedure. If this current value, if I am getting I1 or I2 in the negative, I1 or I2 in the negative, then you have to reverse the current, this direction. Draw the diagram again and you reverse this direction. Here you see what we have done actually, simply if I want to tell, we have not written KVL expressions. You have to draw the current directions and so many things. We have not done that. Instead, we have gone for a shortcut method. That's all. This will be easy. Fine. Thank you. We will see in the next class.